To fine-tune rotax-max following a successful calibration, the first task is to visit your local track and prepare for the fine-tuning session. Locate your temperature and humidity sensor in the shade approximately 6 inches above ground level. Hopefully you are utilizing the JetTech Weather Pro, designed for use with all rotax-jetting.com software systems. To fine-tune rotax-max is a simple process but requires a methodical approach. First, starting the software, unlock, revealing the adjustment features of rotax-max. First, select a preset, either DD2, the Senior Max, Junior Max, Mini or Micro Max. In this example I will use the Senior Max. Next, select your spark plug type, either NGK or Denso. Then your needle selection, either the K27 or K98. Let's leave the K98 selected. Next, your float and idle jet combination, either the old 5.2 gram 30-30 idle jet and emulsion tube or the latest new combination of 3.6 gram floats with 60-60 idle jet and idle emulsion tube. Finally, select your carburetor float height. Float height should be measured as illustrated here, with the carburetor float bowl and floats removed and the carburetor inverted. I simply have a flat piece of plate that is 2 mm thick. Having removed the float bowl gasket, I place it directly on the float bowl mating surface and, using an electronic vernier caliper, measure down to the top of the float lever arms and then simply add 2 mm to this measurement. The standard float setting for the Rotax's Del Auto carburetor is 6 mm, and during this initial fine-tuning session let's leave 6 mm as the float height. But of course this measurement must be made so that you can accurately enter here the actual float height your carburetor is set at. Now, enter the weather information from your weather station. Now, put a 165 jet in your carburetor. Ignore for a moment the needle setting, which we will set later, and go out and complete 10 laps on your local track. Come back to your pit area and inspect the spark plug, the piston crown and the exhaust header. Now, I would imagine at this initial jetting factor setting of 480 you will be rich. So, having established that you are indeed at a rich main jet setting, again enter the weather conditions at the time, and now dial down the jetting factor to 1 jet weaker. As you can see, these blue bars move from right to left as the condition is weaker, and from left to right as conditions are richer, normally in response to a change in air density, but adjustment of either the jetting factor here or the needle factor here, which we will complete later, the bars react in the same way. Now put the 162 jet in your carburetor and go out and complete another session. Again, on returning to the pit, inspect your spark plug, piston crown and exhaust header. By repeating this process, either by again going weaker 1 jet or richer one jet, you will establish this figure. Here displayed as 464, this is your jetting factor. This process matches the software with your particular carburetor and engine combination using the JetTech software's internal dynamic simulation model, which precisely matches the fuel and airflow characteristics of your carburetor to the software and the engine. Having completed possibly 2 or 3 track sessions, you will have established the main jet jetting factor. You are then able to move on to the needle factor. Adjustments of the needle clip selection affect the mid-range performance of your engine. So therefore your pit team and of course the driver himself or herself need to concentrate on the mid-range performance of the engine. Having established a main jet factor, you now need to repeat the same track sessions, but this time concentrating on mid-range performance, so acceleration away from corners. Again, the methodology is identical. Enter the current weather information, and select the needle clip position by changing the needle clip position on your carburetor, in this case the K98. Go out and complete a track session, this time concentrating solely on performance. Let's imagine the driver reports sluggish acceleration from the corner, so let's go one clip weaker to P2. Therefore lift the clip higher in the needle. That has the effect of lowering the needle within the needle jet of your carburetor. Enter the current weather and dial down the needle factor one clip position. It is now set at P2. Adjust your needle to match the P2 position and complete another track session, again focusing on mid-range performance. Having completed these sessions, you will have established your needle factor for the K98 needle. Now you may want to extend the track session and establish a needle factor for the K27, which of course you can do by again entering the current weather information and then adjusting this clip position to optimise for the K27. By that simple process you perfectly match the air and fuel flow characteristics of your carburetor with the software. Next time you arrive at the track, wherever it may be, you simply enter the current weather information and place the 162 main jet in your carburetor and the K98 needle at P2. You would then achieve the optimum performance, having previously established your jetting factor and needle factor. The JetTech software's dynamic simulation model maintains optimum jetting for that particular carburetor. The beauty of this system is simply that, having established the perfect air and fuel flow characteristics for that carburetor, you simply enter the weather information and the optimum jetting is displayed.